Okay, so now we're going to use box plots. We're going to do a little bit of data analysis to look for outliers in our data. So let's load in our usual data set for this chapter. And let's try and construct a box plot. And what this does is it creates box plots. What we do is we send it growth, we send it value, so we send it two different data series. We send the title, and we send an X label, which is the average return in percent, and we add the names of the actual data series, and then we got the color, which we've said gold, whether it's horizontal or vertical. Say, for example, I put false, and I'm going to put green. Let's just see what happens this time. There we go. Now we've got vertical and we've got green. Let's put it back because I quite like that gold color. Okay, let's get back to the gold version. Here we go. And let's just take a little snippet of this. Okay, so this here is the Q1, this point there. This is the Q3, the third quartile. This is the median of the Q2. I'll put in brackets Q2. And, this length here is the IQR, which is Q3 minus Q1. Now, basically, one way of checking for outliers is we have this IQR, and we check from the edge of the box 1.5 times the IQR. And we'll do this in the direction. So we have 1.5 each way on the IQR. And if there's any point, if the minimum or maximum is within this range, then this is set to be the minimum or maximum. So here, this is the maximum point, which is in the range, which is fine. But the minimum point is not actually the minimum point. It's the minimum point excluding this here, which is the outlier. Now, outliers can be a little bit controversial. Some people say you should never remove them, but sometimes you might have a bad measurement, or you might be building a model of house sales price, and you might have a house that's an absolute, it's got 6 bedrooms. It was originally a luxury house. It has loads of high-end features, but somebody's kind of smashed it up, or there's been a fire. And so it's selling at a huge discount. And this one house is like really hurting your model because, it's been through a fire. So sometimes identifying very different observations, outlying observations, and removing them can actually help your modeling. But that's something we'll discuss later in the class. For the moment, we'll just kind of get rid of them. So here we're just creating a box plot for growth. And let's just have a look at this. We're not actually, coloring it or anything. Now, if you have an output from a technique, so in this case, it's a box plot, you can see what information's there by saying names. So names and then the box plot. And you can see that there's actually some additional information besides the plot. And one of those pieces of additional information is the outliers. So here we are. What are the outliers for growth? Well, there were no outliers. That was that second graph I showed you here, the growth, there were no outliers, but there was an outlier for value using this method. So let's just see what we have for a value. And let's just do both of these together. So you can see we've got the outliers for value, and there's one single outlier, which is this point here, -46. And we decide we want to get rid of that. So we've created, what this has done is it's created a new column called new value. It's always good, it's a good idea to create a new column, never to delete your original data. So it gives new value, and basically, I think we had this function before, if else. So if else, each of the values in my data.value, if it's in the outliers, then we turn it into an NA. Otherwise, we return the original value. So let's just kind of do this. And then we're going to do my data.new value. And you can see that it's now got an A where the -46 was. The other thing mentioned in the book is this idea of z-scores, which I'm sure you've covered a lot already in business stats. And that's the standard score, where it's how many standard deviations your observation is away from the mean. So what we do is we take our values, so in this case growth, we subtract the mean, so subtract the mean of growth, and then divide by the standard deviation, so divide by the standard deviation of growth. And I'm going to call this z growth. And we're going to also do the same for z value. And we're going to create these z-scores. And now let's look at my data. And you see we've got the new value, and we've got these z-scores. Now, if you look very carefully at the z-scores, you can see generally an observation above or below 2 standard deviations is outside of 95% of the data. And something above 3 standard deviations is like above 99.9% of the data. More extreme than 99% of the data, 99.9% of the data. So you look where we had an NA in the new value, we actually have a really extreme distribute value. This -46 was in fact quite a long way to the left of the distribution, and it was like -3.2 standard deviations below the mean, which again is quite an extreme observation. So we could say, okay, we remove anything more than 3 standard deviations away from the mean, and we'd remove this same item. Just to finish up a little bit, let's just go to the whiteboard. Okay, so we had this observation here. So let's just draw a distribution. Assume we have a normal distribution or something similar. This is my distribution, and if we're sticking with the value, the x bar was 12. And the standard deviation was 17.9792. And then say we have this value here, which was -46.52. And what we're trying to do is we're trying to go to a distribution with basically a mean of 0 and a standard deviation of 1. That's what's standardizing it. So we want some z here that is equivalent to the x there. And what we'd say, we'd do that, we'd say the z is basically my xi minus my mean to make it the center of it 0. The center is 12 at the moment. Subtract 12, the center is 0. And at the moment, my standard deviation is nearly 18. We want it to be 1. So we divide by S. And in this case, it would be minus 46.52 minus 12.005 divided by 17.9792. And that's going to be equal to minus 3.26, i.e. this very extreme outlier. So I've just done that by hand, just almost for completeness. And there we are. That's a little exercise on outliers.